Welcome children. Coming to the last topic of the chapter, that is composition of functions. So you can see here we have taken two functions. One is f from a to b and other is function g which is from b to c. The codomain of f and the domain of g are same. So if f and g are two functions, then composition of f and g. Keep in mind this order is important. Whether you say composition of f and g or you say composition of g and f, that will make a difference. So here we are taking composition of f and g, which is denoted as GOF. We even read it as GOF or G of f. So if f and g are two functions, then composition of f and g, which is denoted as g of f, is a new function given by GOF from set A to set C. So from here you will understand why this condition is kept, that codomain of f and domain of g are same. Because of this we are able to relate the elements of set A to the elements of set C under the function composition of f and g, and they are given by f of g of fx is equal to g of f of x. That means the image of the element x under this function, which is GOF or composition of f and g, will be given as g of f of x for all x belonging to A. Same thing we can understand from the diagram. You can see set A, B and C are drawn here. Suppose the elements of set A are denoted by x, then their image under the function f is denoted as fx, and this is the domain of g. Set C is the codomain of g. This is domain. So image of fx under the function g is defined as g of fx. The way image of x is being defined under f, in the same way image of fx is defined under function g. And you could see that because of this set B, we could relate the elements of set A to the elements of set C. So image of x is g of fx. Okay, so now you relate it to the definition. You can see composition of f and g or GOF is a function, new function from set A to set C, such that under this function the image of x. So under this function the image of x is equal to g of fx for all x belonging to A. Then you see there are two examples related to it. First one, both function f and g are defined, and you can see if the composition either way is possible. For that we'll have to check their domains and their codomains. You will find codomain of f and the domain of g are same. So the composition of f and g is possible. And they have defined the images of various elements in the domain over here under function f and under function g. Now after this definition, you are being asked to find the composition of f and g. For that I have first drawn the diagram which can quickly help you in understanding and defining the composition of f and g. So domain of f, codomain of f, or domain of g, you can say this is codomain of g. All the elements in the given sets are written. Now let us do the pairing. You can see the definition. 2 has got image 3, 3 is having image 4, 4 has image 5, 5 is also having image 5, because it says f2 is equal to 3. That means image of 2 is equal to 3. Image of 3 is equal to 4. 4 and 5 are having images 5. Then under function g, 3 is having image 7, 4 is having image 7. Then 5 and 9 also have got same image, which is 11. So once this pairing is being done, you can easily see how the elements of domain of f and the elements of codomain of g are related to each other under the newly defined function, which is composition of f and g, or you can read it as GOF or g of f. Okay, so we are ready to write composition of f and g. See to what number 2 is related to now. 2 is related to 7 because of 3, because 2 was related to 3 and 3 is having image 7. 2 was having image 3, 3 is having image 7. So 2 is having image 7 under this new function. In the same way, 3 was having image 4, 4 is having image 7. So the image of 3 is 7 under the function g of f. In the same manner, 4 was having image 5, 5 was having 11. So 4 comma 11 is the next pair. And 5 was having image 5, and then again this 5 was having image 11. So 5 comma 11 is also one of the possible pair here. So we could relate all the elements of domain of F to the elements of codomain of G, and composition of F and G was defined. Now another example of the same type from exercise 1.3. This is question number 3. Both the parts are done. You have to find fog as well as GOF. That means composition of G and F and composition of F and G. But you will see here the domain and codomain of none of the functions are defined. So if that is the case, it means the domain as well as codomain of the function is set of real numbers. So F is from R to R, G is also from R to R. That means both way the composition can be defined. You can even define F of F, G of G. Okay, let us attend to the two which are being asked. Fx is defined as mod of x. So image of x will be mod of x under the function f. Then gx is defined as mod of 5x minus 2. So image of x will be mod of 5x minus 2 under the function g. So defining, first here I have defined composition of g and f. So mapping under g will take place first, and under f it will take later. So let us take element from the domain of G, which is x. In simple terms, we can even write it as f of g x. Now gx is defined. Gx is mod of 5x minus 2. So the image of x under g is mod of 5x minus 2. And now what is our function? F of mod of 5x minus 2. So we have to find, see the function f. Image of x under f is mod of this number x. So what is the only difference among these two? In place of x, we have mod of 5x minus 2. So if I have to define the image of mod of 5x minus 2 under the function f, we are going to use this definition. You will simply replace x by mod of 5x minus 2 in the right hand side. So what does it reduces to? Mod of the given number, and the given number is mod of 5x minus 2. So mod of mod is given to us, which is same as modulus of 5x minus 2. Then composition of f and g. So here first mapping under of f, then it is under g. We'll first write it as g of fx. So we are defining image of x under f first. Now fx is mod of x. So it is now reducing to g of mod x, and g of x is defined. If it is image of x under g, it will be written as mod of 5 times this number minus 2. So what is the difference? In place of x, we have got mod of x. So you simply replace x by mod of x in this definition. So it becomes modulus of 5 times, in place of x, we have mod of x. So I write mod of x minus 2. This is composition of f and g. Then if, see this one to understand it further better. In this case, fx is defined as 8x cube and gx is defined as cube root of x. So finding composition of f and g, which is written as g of fx. So g of fx is how much? 8x cube. Now you have to find the image of 8x cube under g. What is the image of x under g? It is cube root of this number. So if you are finding image of 8x cube under g, then it will be cube root of this. See again, as I told you, you have to simply replace x by the given number on the right hand side. So if image of x is cube root of x, image of 8x cube will be cube root of this number. Now cube root of this comes out to be 2x. So composition of f and g will be 2x here. Okay, that means under this function image of x is 2x. Now finding composition of g and f. Okay, so we will see what is the image of x under this function. We write it as f of g of x first. Now we can use the definition of gx. Gx is x to the power 1 by 3. So gx is defined Now we will find image of this number using the function f. Now fx is defined as 8 into cube of x, means cube of this number. So x will have its image 8 times cube of itself. Here in place of x the number is cube root of x. So on the right hand side you have to replace x by cube root of x. So fx is 8x cube. That means f cube root of x will be 8 times. In place of x, what will you replace? X to the power 1 by 3. You will write x to the power 1 by 3 in place of x. Okay, so 8 times cube root of x whole cube. So cube of this number, and here in place of x we have cube root of x. So cube of x to the power 1 by 3. This gets cancelled out and we are left with 8x. So composition of both are defined.